A sort of dessert course, if you will, in the area of spectroscopy is what are called N to pi star transitions that are present in carbonyl compounds. Okay, so far in this unit on ultraviolet and visible, we have been talking exclusively about conjugated molecules, conjugated alkenes mostly. And it turns out that non-conjugated carbonyl compounds absorb weakly in the UV region. And keep in mind the word weakly. The intensity of these absorbances is usually about 1,000 times weaker than that for conjugated alkenes. So acetone, for example, common substance, will absorb very, very weakly at 280 nanometers, but its absorptivity or extinction coefficient is only 15, whereas, for most conjugated alkenes, they're in the thousands. So what's going on here? Well, in all compounds that we have looked at so far, the HOMO is a pi bonding molecular orbital because alkenes do not have lone pairs. And remember the basic principle that any absorption that happens in the UV or visible region involves promoting an electron from the HOMO to the LUMO. Now, molecular orbital theory treats electrons in lone pairs as being in what are called non-bonding orbitals. Okay, we don't have to get deep into the theory other than to say that non-bonding orbitals have to be higher in energy than bonding orbitals. Okay, so that's one of the principles of molecular orbital theory. When non-bonding orbitals are present, they are higher in energy than bonding orbitals, lower in energy than anti-bonding orbitals, and actually they are equivalent in energy to the atomic orbitals from which they were derived. So if there are lone pairs present, and therefore non-bonding orbitals exist and are occupied, the HOMO will be a non-bonding orbital. So the transition then is called an N. N stands for non-bonding to pi star transition because the HOMO electrons come from the lone pair on the oxygen from the non-bonding orbital and are promoted to the pi anti-bonding orbital as the LUMO of the CO pi bond. Okay, so even though it's a CO pi bond, it's not a pi to pi star transition. It's actually a transition from the lone pair on the oxygen to the CO pi star orbital. Okay, so all I want you to be aware of is that this phenomenon exists. But in reality, these absorbances are too weak to be useful for either qualitative or quantitative analysis. If you were to spot acetone on a TLC plate and manage to look at it under the UV light before it all evaporates, you're just not going to see very much of a spot. It's very, very, so much weaker in intensity than a pi to pi star transition. Nevertheless, this is still a topic that the MCAT would like you to know something about, so consider yourself knowing something about it.